Hey guys, welcome back to Bungo's Custom Bikes. Today we are back to wiring. So last week I kind of showed you a little bit about the KZ400 and the NWT setup. Today we're going to be looking at just kind of a raw, built from home wiring setup on the XS1100. Check it out, stay tuned. So today specifically we're going to be talking about the charging and the ignition circuit. These are probably two of the most complicated circuits that you're going to wire on a bike, just because a lot of the, being specific to a specific motorcycle, it's a mouthful, and just all the different intricacies that go along with it. Because everything else like lights, horns, switches, all that is kind of power go in, power come out. Whereas the ignition circuit's a little bit different because power has to go into certain places and come out of certain places. And also you want it to happen in a specific order, if that makes sense. As well as the charging circuit. So the charging circuit obviously consists of your battery, your alternator, or your regulator rectifier. And your alternator can either be like a field coil, like what's on this, or it could be a stator. A lot of different styles, and they're all specific to different motorcycles. So I will include some wiring diagrams that are specific to the XS1100. And I'm going to go show some of the wiring diagrams that are specific to the switches and the bar controls that I have on this bike. So first things first, let's get started on the charging system for this bike. So this jumble of wires is the charging system for this XS1100. As you can see, these older wires here are coming from the field coil and the stator. And these newer looking wires are going to our regulator rectifier, which we have mounted here. So on this bike, like I said, it uses a field coil. So it uses basically an electromagnet to generate an impulse, which is then broken up by the rotor, which is under this cover here. And that signal is then picked up by the stator, which is these wires here, and turned into AC power. And I explained the difference between AC and DC in the last video. Well, that AC power then goes into the regulator rectifier here, where it's rectified into DC power, regulated to 12 volts, and then sent to the battery. So it'll recharge the battery and also power the system. So essentially all we have to do is make these connections. It's very easy to do. So we have on this, we have 3 whites and a yellow. That corresponds with the 3 whites we have on this. The yellow wire goes to a different circuit that we're not using anymore, so we're just going to take that out and not be worried about that. But we connect the 3 whites to the 3 whites. And then on this one, the green and the black correspond to the green and the brown here. So that's also real simple. So we're going to cut these ends off because they don't match, and I'm going to use my own connectors, and we're going to wire all this together real quick. Also off the regular rectifier, you have a red and a black. So there's no corresponding plug to that on this one because the red goes to the battery, the black goes to ground. It takes all the excess power that's being made and sends it to ground. And then everything that it can use goes to the red wire and goes to the battery to power both the battery and the rest of the system. So let me make some connections and you'll see what I mean. Okay, so as you can see, we got all the connections made. Got the 3 whites to the white, the green and the brown go to the green and the black. And then you can see I've got the red going to the positive terminal of the battery and the black going to the negative terminal battery. So that is, in all essence, that is the charging circuit of the motorcycle. From that, the bike will charge itself and charge the battery and run the power off of that circuit. So that circuit is super easy. Now again, that is motorcycle specific. So not every motorcycle is going to be exactly the same. Most of them do run a 3-phase, stator or alternator or generator or whatever it may be. It is typically 3-phase, so that's why there's 3 wires. But not all of them have the field coil. In fact, that is not the most common setup. But next thing we're going to move on to is the actual ignition circuit. Oh my gosh, what happened to your mustache? I don't know. Anyways, the next circuit we're going to work on is the ignition circuit and the run-kill circuit. So they're kind of all in the same kind of category because we're taking power from the battery, running it through a couple switches so that we can control when the bike does and doesn't have power. So the three technically switches that we have to wire now is, first of all, is the ignition switch, so the actual key ignition switch. You turn that on, that gives battery power to the whole motorcycle. Plain and simple. The next one is the start kill switch for the bike, or the run kill switch, which is this switch up here. And that's what's actually going to turn our coils on and off. So obviously you turn your coils on, bike's ready to run. Crank it, it goes. When you're ready to stop the motor, you turn the coils off, motor doesn't get spark anymore, motor turns off and dies. Plain and simple. And the last switch is the actual start switch for the starter motor. And that's just a momentary contact switch that completes the circuit to the starter solenoid and allows that starter motor to kick over. So let's get into detail and talk about it. So first things first, let's talk about the components we need for the main ignition circuit. As you can see, I've got 1, 2, 3, 4 things here. This is the ignition for the motorcycle. It's running the points. It's replacing the TDI and the CDI for this motorcycle. It's just updated. I don't know how to pronounce it, but it's from Germany. If anyone speaks German, Electronic Sachet? I don't know. But it's replacing the points and the TDI box. And you can see it's got its wiring diagram here. So we'll wire that accordingly. The next component, this is the flasher relay. And then this is my actual ignition. I call it a distribution box. But basically it runs main power into here and then distributes it to each of these as a separate circuit. And you can put whatever size fuse you need. And then it has a ground bus here. And for anyone who doesn't know, a bus is basically just, somewhere where all of the wires can come into one main circuit. So I run ground here back to the battery, and then each of these screws is connected to that to run ground. The next thing is the starter solenoid. Normally you like for this to be closest to the battery because we're going to have to run that thick battery cable up here. And the longer it runs, the thicker the cable needs to be to not give too much resistance. This is really the only place I could find to fit it where it's out of the way. So that's where it's going to live. The way this one works is it has your battery. This is battery power. It goes through a 30 amp main fuse and then runs power to these two wires up here. These are both power out from the battery. And then this is the starter solenoid circuit. So when you run power into this, it completes this circuit and starts the starter solenoid. Always good to have a main fuse. This 30 amp is basically, the fuse for the whole system. So what we're going to do for this circuit is we're going to run our large gauge battery cable up to this lead, and then that will give power to the whole bike. And then these two will come off of one. It'll go up to the ignition, and then the ignition, is up here. It'll come off of the ignition, which is this wire. Might be able to plug that right in, actually. That'd be kind of nice. It'll go into there, and then the ignition, when it's switched on, will come back down to here, run power to this main bus, so all the gauges and everything turn on. And then one of these circuits will be for our ignition, so that'll come back up to here, which is our switch, and we switch that on, and it will turn our TDI CDI box on, which will go into the number 8 slot, which is 12 volts in. And then the last thing is we need power from, we'll probably run power from this, so that way when we turn this on, we also get power to the starter solenoid to go to this circuit, and then this just runs back to ground. So that way you can't start the starter without having turned the key on. And the kill switch up here. So let's get all that wired up and I'll show you how it looks. Okay, so this is obviously not going to be the final layout of the wiring either. I'm going to do it much cleaner. I like to do kind of a dry fit and just a layout, see where everything's going to go, and then I'll actually go through and you know, trim to length and put it in wrapping and all that, make it look pretty. But we've got the battery cable going from the battery, it's just dangling right now, but from the battery to the starter solenoid, which gives power through this fuse to this red wire. This red wire is going to come up here through the ignition. This is the ignition switch. It wires up to here. So when you turn this key, it connects the circuit. It comes back through here and will give power to this. And then what we need to do now is we need to trace our power from here. We'll pick just, you know, a random slot, put a fuse in it, and we'll run power from here up to this harness. And we've got the wiring diagram for this harness, and that pins into the, what's it called? The button. So that's what we'll do next. So I actually decided to change things up a little bit. So the two wires that came off this, one is supposed to go to the start switch. But I decided, since I'm going to be running the full power of everything off of these, I decided to double them up to kind of share the load. And it's going into the hot side of the ignition switch. And then obviously the switched side is coming back down here. That stayed the same. But then the other, there's two leads that are switched for this ignition switch. The other one is going to go to the start-stop switch, or the actual start motor for the starter solenoid. So that'll come off that switch. It'll go from the switch side of the ignition to the start button, and then from the start button down to the solenoid, and then the solenoid will go to ground. So that way when you push that button, it connects the circuit, everything's good. However, you still won't have power at that button if the key is off. So easier to show than do it. So I'll wire that real quick and you'll see what I mean. So the handlebar switches I'm using are from K&S. I won't say they're cheapo, they weren't cheap, but they come with the wiring diagram on the back, and they come with little pigtails, which is kind of cool. So you actually know where you can wire your pigtail and then still have a quick connect for that handlebar. But what we need is the ignition system main off run. We need the starter circuit to start a relay, and then main starter fused hot. So the main starter fused hot is white and green, and that'll come off of our ignition switch and go to starter circuit to start a relay, which is yellow and red. So we need white and green and yellow and red off of this. So let's get it wired. Okay, so I've got power to the starter solenoid, or power to the switch, coming off of the ignition. It goes up, goes through the switch, you press the button, it completes the circuit, comes back through the yellow and red to the blue and white, closes the starter solenoid, the red and white comes off, comes to this black wire to ground. So there is the starter solenoid circuit. Now we need to do the kill run circuit, and then that's really it. So let's get that done. Okay, so for the kill switch, or the run kill switch, we want to look back at our chart and see which ones we need. So we need ignition system main off run, and then main off unfused hot. So we need black and red for our power in, and then we need black and white for our power out. So we're gonna run our red wire. I like red wire for the ignition circuit. We're gonna run our red wire to the, I already forgot it, black and red wire from our circuit, our fuse block. It's gonna go up through the switch, and then it'll come back out through the black and white wire, and then from the black and white wire, it'll go to our TDI CDI box. Let's get it done. All right, So we now have the TDI or CDI box wired in. And the last thing, this is really all I wanted to do for this video. You know, I've got the starter ran, I've got the kill switch run, I've got power to the bike from the starter solenoid run. So really that is the main ignition circuit and the charging circuit done. Everything else after that is just running power to a light or a switch and then ground back. And I will make a video about that because grounds are very important, and I'll kind of do a little bit of a video about grounds and accessories. But that's the heart of wiring a motorcycle. Before we leave though, we're going to run into testing. I want to show you how to test your circuits without actually putting power on them. So let's do that real quick. Okay, so in testing, the easiest way to do it is get yourself a multimeter. And I'll show you where I have it set. So a good multimeter like this, or a volt ohm meter, whichever you can find, anything with continuity. So we're basically just going to go down here to the continuity function, that little thing. And what that means now is if we touch our leads together, it beeps and you get that little light there. So we're just going to test our circuit. So the first thing we're going to do is we're going to start right here at power and make sure our fuse is good. So we put one lead here down where the power is coming in, and then one lead on our circuit. And it's beeping, so we know that fuse is good. The next thing we want to test is our actual switch. So we'll come up here, we'll turn the kill switch to off. We'll put one lead where the power starts and one lead where the power ends. And I'm getting nothing. So now we flip our switch to on. And I'm getting good tone. So that means that that switch does indeed break that circuit. And when the switch is closed, the circuit's closed. And that's what we want. So the next thing we want to check is we want to make sure that our ignition is doing what we want it to. So in this situation, I'm going to come down to where the battery comes in. And we'll turn our ignition off first. We'll go where the battery comes in, and then we'll go to one of our leads here that's switched for the ignition. And I'm getting nothing. So next we'll turn our ignition on. We'll go to where the battery comes in, and I'm getting good tone. So that means our ignition switch is good and is in fact switching power. The last thing, and it's kind of hard to test the starter solenoid because we don't have power on it. It needs power to actually close that solenoid. So one thing we can do is we can just make sure that we don't have continuity between the two battery posts. And we don't. When we actually go to put power on the motorcycle, we can see and watch that switch. But for now, that's all I got for y'all. This was kind of a long video, but it's definitely one of the more informative videos I've done. I really hope it was useful. This is really the hardest part of wiring the bike, is the ignition circuit and the charging circuit. After this, it's just taking wires from the power, running it to the switch, and then running it to ground. I mean, it's simple. I will do a video on that, but it's not going to be a very long one. I might do 2 circuits just to show you how it's done. After that, it's going to be a running bike. We got to fabricate the exhaust, and then that's it. So, if you haven't already, please like and subscribe. I have gained quite a few new subscribers. That's awesome. Thank you guys. I appreciate it. But most importantly, keep riding, friends.